Here's our last section in Chapter 9, Properties of Gases. I'd like you to take a few moments to recall the ideal gas law. It describes the relationship between pressure, temperature, and volume for a gas. It describes the relationship between pressure, temperature, and volume for a gas. So, pressure times volume, here it is, equals the number of moles of gas times universal gas constant, 8.31, times the temperature in Kelvin. That's our absolute temperature. In physics, we sometimes write the ideal gas law a little bit differently. Pressure times volume, and then this is the number of gas particles, not number of moles, and then Boltzmann's constant, which I've written here, times the temperature in Kelvin. Let's look at an example. Pure helium gas is contained in a leak-proof cylinder containing a movable piston. The initial volume, pressure, and temperature of the gas are 15 liters, 2 atmospheres, and 310 Kelvin respectively. If the volume is decreased to 12 liters and the pressure is increased to 3.5 atmospheres, find the final temperature of the gas. Okay, well, if we look at PV equals NKT or nRT, it doesn't really matter. The number of moles of gas or the number of molecules of gas times this constant, no matter how you look at it, this doesn't change. So I can rewrite this to say PV over T equals a constant, which means that if I change one of these quantities, pressure, volume, or temperature, the others will change also. In other words, pressure times volume over temperature in one state must equal pressure times volume over temperature in the other state. So they tell us our initial state is a volume of 15 liters, a pressure of 2 atmospheres, and a temperature of 310 Kelvin. And then for our second state, our volume is 12 liters, and our pressure is 3.5 atmospheres. So I can plug this in and solve for my unknown temperature. So 2 atmospheres times 15 liters divided by 310 Kelvin equals 3.5 atmospheres times 12 liters over an unknown temperature. And when we solve that, we get that the unknown temperature is 430 Kelvin.